that you want to make sure before you start working, on a daily basis, make sure that your default change list is the only thing in your pending change list. Make sure you're not building up change lists or have just files sitting over here. Either submit them or remove them before you work every day. So I'm going to go through these 3 experiments right here inside of Unity, and I'll start with the first one, and then I'll give the demonstration, and then if anyone has any questions in between each one, feel free to ask. So I'm not going to be able to get up and come around the room and help you guys troubleshoot. That's what I'll help you do in lab, and that's what you can reach out to me in FSO message or just contact me in my office hours. But lab, that is what that time is for. But for right now, I'll stop and answer any questions in between each experiment. All right, so make sure your pending change list is clear, and remember, as a really helpful tip, always remember you can open your Unity project right from Perforce. So I want to open up my hub scene, so I can just double click right on the hub, and Unity will load, and that project will be open. It's just very helpful to make sure that you're not working in some other project somewhere. And just another reminder, make sure we're working in the same project that you've set up all month long. We want to be using the same project, not a new one every single assignment. All right, so here's Unity. I'm going to go ahead and remove my visual scene. So we have just the hub in here. So what I want to do inside the IND folder, we have the IND2 wind turbine scene. We'll go ahead and drop that in the hierarchy. All right, there's that platform. Actually, for now, what we can do is I'm going to go ahead and remove the hub just so I can just work in this while we're just building the wind turbine and doing the first experiment. So the first experiment is all about complex game objects inside of Unity and how to construct them, how to set up your hierarchy. And why this is important is because you want to logically set this up not only for putting scripts on certain objects, but for animating things. We want our hierarchy to be built in a certain way to where when we rotate that center object right there, the blades follow along with it. So we're not animating 4 or 5 objects, it's just one. And the structure of the child-parent relationships are set up in a way where all the heavy work is done for us. We just need to animate one piece of it. Same thing goes where when we rotate this, we don't want this whole pillar to be rotating at the same time, right? We want that to be stationary, but then we want to be able to move this whole object as one piece, as one prefab in Unity. So we want to set up our hierarchy in a logical and structured way. And when we do this, it's definitely important to understand you want to take the time to do this before you actually animate, because once you start animating, you might end up having to rework the object if you want to make changes, and then you have to rework the animation. So take this step seriously and get your structure right so you don't have to rework the animation later. So I'm inside the wind turbine scene. So I'm going to go into what I'm actually going to do is I'm going to showcase a feature called revert unchanged files. So this is a really good, helpful piece of information. And Jacob, this may help you as well. So I want to make changes to one of these scenes in here, right? The visual scene. I may end up changing the hub. So what I'm going to do, I'm just going to check out the scenes folder. So what that's going to do is that's going to check out every single file in that folder. All right. So now I'm going to come back over here, and now I'm just going to start to work on my wind turbine. So the first thing we're going to do is we're going to create a 3D object, and we're going to create a sphere. All right, so in the inspector, we're going to call this object pivot. And now whenever you're building a prefab, it's really, really good to build everything at the origin, right? So 0, 0, 0 in the position and 0, 0, 0 in the rotation. We want to keep that clean at the origin for when we're starting to parent things together. All right, so from there, the next thing we're going to need is let's create a capsule, and these are going to be the blades of our actual wind turbine. All right, now again, let's just put it at the center. And now for this one, we want to scale this 3 in the Y and 0.25 in the Z. All right, that's just to give it a little bit more resemblance of an actual blade, what it would look like. So now what we're going to go ahead and do is duplicate this twice. So we got 3 of them. Oops, and we want to rename them too. Blade. Actually, let's call this blade 1. Could have renamed it and then duplicated it. Would have had to save from actually renaming them all. All right, so now with those, now with those in there, we want to just create a parent-child relationship. So to do so, what we want to do is select all of our blades and drag and drop them right into the pivot object. So before you do this, make sure they're all set to the same 0, 0, 0 in the position, and then go ahead and drop them in there. So what this does is now you'll see this little drop-down arrow here. This may be a review for you guys, and that's okay, but the point we're making here is tied to the animation and why we're taking the time to set this up. So now with that pivot, you'll see when we move this object, everything goes with it, right? All the blades, which are all on top of each other right now, everything is parented together. So set that back to the origin. All right, so now we just want to rotate our blades into position to get them how we want. So what we can do is just start to rotate each one 60 degrees positive and 60 degrees negative. So I can use Control to snap, and that'll rotate one more. Sometimes it gets off, and my OCD wants it exactly perfect. So rotate it that way, and then negative 60. All right, and now you'll end up with this flower type of pattern. So still just do a check, rotate, make sure everything is normal. Everything's working how we want it to. So from here, we want to just move them into position. And you'll notice with the way the pivot is set up right now, the way the widget is, it's set to the world. So if we want to move this, actually slide this blade how we want to, we'll have to move it on 2 axes and try and line it up just how we want it. Not the best way to do it, still workable, but Unity has provided us with this really helpful button up here, and we talked about it a little bit when I went over the level blocking meshes. So I can toggle this. This will toggle between the center and the pivot of the object. Well, remember that these are the same location, but over here you'll see this global and local. And you'll see when I click on that and I switch to local mode, what that's doing is actually changing to be the local of this object, right? So now the up vector of this, the y-axis is pointing this direction. So I can now just move this on that axis. Makes it much easier to move a certain object to its own local position, not the world space. Everyone understand the difference when I say local and world? What that means? Okay. So the world is always, y is always up, right? But if you rotate and move an object, say I rotate this blade, so now the y is now almost down, right? The negative. All right, so we're just going to slide these into place. And you can get them exact if you really want to. But the point is to understand is that now when we select that pivot object, make sure that's selected and we rotate. So make sure now that we're on the center or the pivot of that object. When we rotate, it's going to resemble the motion that we want to end up with. So make sure that nothing is skewing or being distorted. Sometimes if you scale your pivot or you start to add scale values to things, you'll have some really weird skewing and distortions. So it's really important to set up your hierarchy and test it along the way. All right, so the next thing we need is the actual base that this is going to sit on. So we're going to create a cube. And let's call this head. And let's go ahead and create a cylinder. Let's create a level blocking cylinder. All right, and now let's go ahead and put this at 0, 0, 0. Let's call this guy stalk. All right, now I'm just going to make this guy a little bit larger. Now this is just adding a little visual touch to it. You can definitely, going forward in level design, or if you're building something that you want to end up in your level, take the time to put a lot more detail into it, or put some effort into, including the look as part of the functionality. So I'm just going to make this, we'll go with about 8 units, maybe a little bit larger, 10. I don't want to do anything too big because otherwise when you actually go to test it, you have to really look all the way up, and you want to see the interaction as soon as you press E. Because that's what we're going to eventually be doing here, is setting up an animation and interacting with it as a player to be able to turn this thing on and off. So now we have our head and our stalk. So now what we want to do is set up this hierarchy as well, to where when I move the stalk around, I want the head to follow with it. So I'm going to take the head itself and drag and drop it into the stalk object. All right. So now what we want to do from here is we want to group these together even further. But what's important to understand is we don't want the stalk to be a part of the pivot, right? Because we want this to rotate just as it is now, right? Excuse me. We want it to move just like this. But we want to be able to move this whole thing as one unit around in Unity, right? We can make a prefab, drop it in the world somewhere, and we want it to move around as one piece. So what we can do is create an empty game object. So I'm gonna right click on the stalk and create an empty. The only reason I'm doing that, why I'm creating the empty inside the stalk, is just to get that location. That's the only quick shortcut I'm doing. So now I'm just going to drag and pull it out for now. So now you'll see I have that location, so I can just, oh, that scale value screwed me up. There's another good example to where that scale value is the opposite of what I'm wanting. But there we go. So we have the game object clean. That's where we need to start. So what I did actually didn't matter at all. Perfect. So we're just going to name this wind turbine. This would be the overall object that everything is grouped under. And the reason why we're doing this, again, is just to have everything in one nice convenient package. So we're going to go ahead and drag and drop these guys into the wind turbine. So now I can take the wind turbine and move this around, and it moves as one piece. Another reason why this is super important is because when we animate something, so we want to animate this pivot object. If we animate this wind turbine all the way up the top, the root object, that is that using that world space. So what happens is that you can't have instances of that throughout the world, because it's always going to revert to that same location. So you always want to make sure that your animator is on some object that isn't the root. That makes sense. So you don't want to have an animator all the way at the top of your chain. So now that's the case, what we want to do is position this in a way that makes it easy for us to actually drop these in the world as well. So you'll notice now that where the pivot of the wind turbine is the same pivot as the actual pivot object. What we can do is, if we shift select the pivot and the stalk, hold down and grab both of those and move those into place. All right, so I'm just using control to move and then snap so it ends up right at the origin. Now when I actually go back to the wind turbine and select this object, notice that my pivot is now at the base of that now what is going to be a prefab. So before it was pivoted here, but now it's here. So what's important to understand there is I can move the child objects all I want to. Right, I can move this thing wherever I want, but that wind turbine game object, the parent, is staying in the same place. Alrighty, so now that's the case. We've got our prefab. Everything's working. Definitely test it again. Make sure your pivot isn't moving. Your pivot is moving. Your head and stalk aren't. Make sure we have our structure right. Now we're good to go. So let's go ahead and save the scene. And let's also go ahead and create a prefab now. This will be a good practice. So I'm going to put it inside my student name folder. is a good place where you can start to put any assets that you're creating or building that you want to either include later on or you just want to have a collection of. Let's go ahead and create a prefabs folder if you haven't already done so. Now I'm just going to take this wind turbine and drag it into this prefabs folder. All right. So now again, I'm just going to save the scene and save the project. All right. So now remember that I had checked out my entire scenes folder, right? But I necessarily didn't make any changes to the hub yet. I haven't made changes to any of the other assignments or any of the other scenes. So what we can do in here is do a revert unchanged files. So remember, revert files is just going to take everything out of the changes and just remove it, right? So you made a mistake, you added your library folder accidentally, or you added files you didn't necessarily need. Revert files will just take them out of your change list. When a change list is empty, then you have the option to actually delete it. Revert unchanged files does the same thing, but that one word difference, unchanged, means anything that's not changed, right? Anything that's the exact same, let's just take it out of the change list. So I hit revert. Look, we're left with just one file, that one file I changed. So this is a really good habit to get into. This will also help you catch any meta files that change. So definitely know that that's an available route to take. So now with that in there, also remember I just created a prefab, and that's an asset I need to add. So remember I can go into my folder in the workspace side. All right, so there's that meta file. I'm just going to drag and drop that in there. And here's that prefabs folder itself. I'm just going to drag and drop that in there. All right. So now I got some files marked for add, one file that I had checked out and worked on. Let's go ahead and submit this. So what you're going to be doing here, and this is part of your ILA assignment for next week, so a whole week from today, but if you are a go-getter and want to get this done either in lab or the next few days or over the weekend, feel free. This is part of the doing the ILA. You're going to take a screenshot of your history. So basically, I'm just going to write completed wind turbine experiment number 1. So then eventually, when you're done with all 3 of them, you can come over to your history here and then make this window so you can see right here, and then you'll just take a screenshot of this and submit that to FSO as your ILA assignment. That's coming up, but what we're doing now is I'm just showcasing it to you now, so when you see it again, it'll be a refresher, and you'll be able to pick up the information even better. So we've got the prefab added, and I've made a change to my scene. Anyone have any questions at all about the first experiment? No? Pretty straightforward stuff, right? Any questions at all from the online folks? And if you guys have any questions at all throughout the whole thing, feel free to just interrupt me if you have a microphone. Sometimes it's tough for me to see the little chat box while I'm doing the lecture. All right, so moving on to experiment number 2. This experiment is all about the animation editor and the animator inside of Unity. So really, really helpful stuff. Really my background, I really enjoy modeling, of course, and texturing is okay. It's definitely can become very tedious, and it's fun to do, but I really, really enjoy rigging and animation. So I think I enjoy it so much because it is a technical thing. A lot of animation is reading graphs, surprisingly. So hopefully you remember what slope is, because we're going to talk about it a little bit today and how it can actually affect your animation. All right, so also what I'm going to do at this moment in the assignment, what I'm going to do is showcase what's called reconcile offline work. And this is something that is helpful to use and understand, but not necessarily a workflow that you should be using. And you could probably ask some of the Des 3 students about why this could be a nightmare or why it could be a really big benefit to you. So what reconcile offline work actually does, here's right here, is it scans your assets or scans whatever folder you have selected for any changed files or any new files, anything different. So it's going to scan your workspace and scan the depot, look for any differences, and then mark those files It's either going to check them out, mark them for add, or mark them for delete. So that's what it's going to actually do. So what I'm going to do at this point in time is just showcase that, and then I'll explain why you would want to use it and why you wouldn't even further. So I'm not going to check out anything. I'm not going to change any files. So this is just going to demonstrate how that process would work. So right now everything is still read-only. Okay? So back inside of Unity, I got my prefab. And what we're going to do now is we can go ahead and move this guy into place. All right. So now what we're going to do from here is start to actually set up our animations. So what we want to do is go ahead and just go to Window, Animation. So when this window pops up, you'll see that it says no animatable object selected. Anybody have a guess? What do you think we need to do? I heard pivot. What was the rest of that sentence? Yep, add the pivot, or select the pivot object. So we just need to select the pivot object in our hierarchy. And now it'll say here, to begin animating pivot, create an animator in an animation clip. It's like, okay, so we can hit create. And now we're going to create an actual animation clip. All right? So the first thing that we're going to create is we're just going to call it idle. So this is going to be when our wind turbine is just in the off state. And now I'm going to go back and put this inside. Oh, let's see. Let's definitely stay organized. Where should we put this? Let's keep it consistent and put it inside. So inside the assets folder, I'm going to create a new folder called animations. And it's really up to you how you want to stay organized, but it's important to not to just throw everything in one folder. And the reason, honestly, is one, it's going to be much better for you guys to collaborate and bring everything together, and two is for Perfor's sake. To be able to come to just one folder and mark for add or just submit that folder will be much easier than have everything scattered all over. You definitely can, but you have to stay conscious about what it is you're changing. So now we have this idle clip here. You'll see this window here is where you can select different clips or create new clips for that object. Up here, this top row of this top set of buttons up here, this record. Anytime that this is checked on, that means any changes you make inside of the editor are being recorded inside of your actual animation. So be careful with that. This isn't something you can undo. You'll have to end up just going in and start deleting keyframes and fixing it. So just be conscious with that. This play right here, this will basically give you a preview of your animation once we set up some keyframes. This basically lets you jump from keyframe to keyframe. And a keyframe, if anyone isn't familiar, that is basically just a little blip on this timeline, right? And this basically will just represent at a certain point in time, this is at this position or it's at this rotation value. And that is what a keyframe is represented. It's just a point in time that an object has a certain position or motion to it. So here you'll see this add property. So now we have our pivot selected. We want to go ahead and add a property. Anyone want to take a guess in what property we want to add to this? What is the property we actually want to animate? Transform, yep. Rotation, exactly, yep. And make sure you don't double click on this. And if you're working on a really small window, like something like this size, no, it's maybe my monitor, but sometimes you won't actually see these pluses, so make your window a bit bigger if you don't, and then you actually hit this little plus sign here. All right, so by default, it's just going to add two keyframes for us, one at the beginning and the end, quote unquote. So Unity by default is just going to make your animation clip 1 second long. For the idle, that's totally fine for us. We don't need anything bigger, but feel free to just, if you want to make this bigger or smaller, and you can just use the scroll wheel to make this, to see more or less of the timeline, you can just click and drag your keyframe out to make your timeline, or make your animation longer, and you'll see that bar goes from a darker gray to a lighter gray color to showcase where the animation stops. And if you ever want to preview your animation, animators use the word called scrubbing to scrub through your timeline, you can just click up here in the timeline itself, and you'll see that red bar right here represents the point in time that you're at. All right. So now you'll see that we have these two keyframes. If we hit play, we don't have any motion, but that's okay. This is what we want for our idle, right? So we are officially animators now. No, not even okay. Not even a pity laugh. There we go. So from here, what we want to do is create other clips to actually have the different states of this object. So in the animator window, this is where we set up the states themselves and how we transition from basically on to off, or whatever number of states we create. The animation window is where we create the clips themselves. So now that that's done, you'll notice down here we have the dope sheet and the curves. All right, so the dope sheet, this is basically just a left to right indication of your different keyframes represented as small little diamonds. You don't get any extra information from this. But if we take a look at the curves, this is more representative of an actual graph. So we'll take a look at one of these. You'll notice that this is just a flat line, right? So remember I was talking about slope and why that's important. So can anyone tell me what the slope of this line is? 0, exactly, right? So and basically a slope value of 1 is a line that's practically perpendicular, right? It's straight up and down. So why that's important is the closer you are to 0, the motion is just at rest, right? Because on the left over here, this is would either be our transform or rotation value, and the x-axis is time. So this over here is basically no change over time. And going forward, I'll showcase a few other, basically another few examples of common graphs you'll see and how you can adjust going forward. So let's go ahead and create another clip. So let's create a new clip here, and let's call this spinning. Make sure we put it in the same folder as that assets folder. And I'm being such a bad student and not renaming this student name folder. So if you guys want to, feel free to do so. So in here, I'm going to go ahead and add the property again. Another really helpful thing to start thinking about, and I'll mention this again later on, but look at what we have, look at these other objects we have access to, right? So we have that transform, which is what we are animating here, but we have all the other components of this object, right? We could animate the collider, we could animate the mesh renderer to be on or off, or to do something, right? Yeah, we could animate it to be enabled at a certain point. We have access to all the child objects. This is really important when you actually do your entryway, because think about if the very common entryway, like that door, or if you do a very basic door like the one back there, the handle, right, you can have that on one animation. One of these objects could be handle, and you animate the door to swing open, and at the same time, on the same animation clip, you animate the handle just to rotate down and open up. Right? Very easy. You can just have one animation rather than having this has an animator, this has an animator, and they're all have to work at the same time. Have it set up in one logical way. So we're not using this yet, but think about, again, your hierarchy. Anything that's a child object you can have access to in the animator. So add this rotation. All right, and now all we're going to do here is we're just going to create a looping animation. So we want to drag the timeline all the way over to the 1 second mark, and we can go ahead and rotate this in the Z. Let's rotate this 360 degrees. All right, now let's hit play and see what it looks like. So now you'll see we have a looping animation. So in the preview window, as soon as it gets to the end, it's just going to play at the beginning again and go over and over and over again. All right, so now if we take a look at our curves, let's take a look at the Z. So the slope of this line is constant, right? There's no change in it. It's a constant slope from 0 to 360, the same slope, which means it's going to be a constant movement, right? Constantly looping over and over and over again. So what we want to do is we can manipulate these tangents on these lines themselves. So if you right-click on the keyframe, you have access to the tangents of that keyframe, right? You'll see these little handles come up, and you can adjust and move them to get the motion that you want. So this may look a little weird on this motion itself, but having things fall over or knocked over or adding force to them, starting to understand the graph will be able to allow you to communicate that stuff inside of Unity, inside of your game. So if I go ahead and make this flat, right, that's setting the tangent to 0, right? So by looking at the graph, we can start to read and see what's happening. So I'm going to do the same thing on the other side and just drag and adjust this. So before I even reveal what's going on behind here, and I promise it looks real crazy, if we just look at this graph, anyone want to take a guess as to what this motion would look like? Yep, it's going to start really slow, and then speed up really quickly. Definitely, really good stuff. And I'm going to make this a little bit larger so we can see it faster, or see more of it over time than just 1 second. Let's go make it 2.5, and put it at the beginning. So it's going to start real slow and then spin up. Oh, and it looks like by adjusting those keyframes, see how my tangent got tweaked a little bit. So that's why it was spinning the opposite way. Oh, this tangent got screwed up. So you'll see these little handles. You click on the keyframe, and then you can just adjust the handle. So now it'll get that motion. So you could have like a wind-up animation. Say, I'm just going to show you guys, that's maybe something I should add to this assignment, is basically I'm just going to showcase an on and an off state, but you could have this one in between, right? This is basically it winding up to start spinning constantly. That'd be a good thing to actually add in. So you can definitely play with these handles, right? While this is moving, we can see what is actually happening with this, and definitely the tangents. Remember the tangents and what's going on to see what this motion actually looks like. So this would be start out real fast and slow down, right? Fast, 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 slower, slower, come to a stop. All right, and then if you ever want to, you can always just, I think, go back to auto, and that'll get you a linear. Yeah, so auto, flat, broken. If you ever have like a keyframe in the middle, broken basically lets you control the left and right separate from each other. So take a look at those. Really just enjoy kind of just experimenting with it, and that's the best way you're going to learn from this. As long as you understand now that a lot of this is just reading a graph and time and distance from each other, you'll start to pick this up, and it'll really show in your work. So the other thing to pay attention to, it looks like I have some keyframes on top of each other. Let's go ahead and get rid of that. But make sure I have this set. All right, cool. So the other thing to understand too is basically the understanding time. So having this object spin 360 degrees for 2.5 seconds. If I wanted to make this faster, make it spin faster, anyone have an idea what I could do? Yeah, bring the keyframes closer together, exactly. So the closer the keyframes are together, it's still traveling that same distance, but now it's doing so in a shorter amount of time. So the closer your keyframes are together, the faster the motion. The farther apart, the slower it is. All right. So now we got both our clips. Definitely just test both of them, make sure that they're working fine. I'm actually going to take my idle and make it a little bit shorter, and this will make the transition period on it a little bit faster, transitioning from idle to spinning. So we just test them both, make sure they work. And now once they're done, I'm going to go ahead and just close the animation window, because I don't necessarily want, I don't want to be recording or accidentally record something I didn't want to adjust. So now you'll see inside of the animator window. So go to Window, Animator, and we pull this off over here. All right, so if I select the pivot object, notice what we've got in here. We've already got some, see if I can make this bigger. We've already got some states in here, right? So for every clip that we were creating, Unity was creating one of these states for us. So we have this idle and spinning state right here. And then way over here, so we have this entry state. So way over here, we've got this exit. So what this entry and exit state are basically when this object is instantiated in the world, or when it first is awake, where does it start? Where is that entry state? And when it exits, or basically when it is destroyed, when it's removed from the scene, any way you do so, what is that exit state? So by default, the entry state should be attached to something, and exit isn't required. But that's what that's used for. So like characters, that would be a common thing. Like if you have AI or something that's spawning, as soon as the AI spawns in, what is the state it's in? Is you want it to be walking? Is it going to be idle, attack, things like that. The layers and parameters, don't really worry about using layers right now. You're not really going to be using it anytime. Maybe use it in final project, but really like the best explanation I could give for a layer would be like you have a character, like our character would be, and then you have a crouch, right? So for the normal character, you have walk forward, walk left, walk right, walk back, right? Those are all 4 different animations that are set up based on input. And then when the player crouches, you have crouch forward, crouch left, crouch right, crouch back. Those are 4 separate walk animations. So you could have a layer in here called crouching. It's the whole separate different animations for the same input. Or swimming, right? They have a swim. The player's in water and they push W. They're not walking anymore. They're doing a swimming animation. So that's what layers are used for on a big term sense. You may find a use for it, but really the parameters is what you're going to be getting more familiar with. So parameters, if we go ahead and take a look at it, we hit add, you'll see float, integer, and bool. All these terms should be already familiar with you. You should understand the differences between those, and we'll go over using I will show you an example with a Boolean. A trigger is a bit different, or this is specific to an animator itself, but you can think about it almost like a Boolean, but instead of it being true or false, it just triggers and happens. So it's basically set to false. If you wanted to compare it to a Boolean, it would be it's set to false, and as soon as you mark it true, it triggers and then it gets set back to false again, just automatically. So really cool stuff. I can show you a student example that uses it, and just helpful thing you could use to do your entryway. So now we have these 2 states here, idle and spinning. If I open up and see my hierarchy while I have these selected, make this a little smaller, you'll see some information about this state itself. So this motion right here, what this actually is that clip that we created, right? This idle clip right here is what that motion is. So you'll see in my project here that this pivot, you'll probably wondering what this is. This is called an animation controller right here. So pivot.controller. This holds all this information that we're about to adjust and create right here. So what we want to do is set up transitions between these 2 different states. So how we can do so is we can right-click on the state and we can click Make Transition. All right, and now you'll see we have this little arrow and we can snap it to whatever we want to. Same thing for your entry state. If for some weird reason it's not set to the state you want, you can just right-click on Entry and do Set State Machine Default State. And wherever you attach this to, this will now make that state the entry. So if that ever is the case, make sure you change that. Okay? Then from here, we can actually change what this transition actually needs to have happen before it will actually go through and happen. So those are what's called conditions. So transitions and conditions are 2 things that sound very similar and work off of each other. All right, so let's go ahead and make another transition back. So now you'll see it's in this looping pattern. So before I hit play or showcase anything, does anyone just want to take a shot in the dark and just say, what will happen if I play in Unity right now?
Start spinning and then idle, spin, idle.
Yep, exactly. So it's gonna, as soon as I start, it's gonna idle for the length of the animation. It'll start spinning and it'll come back to idle, and it's just gonna play each one back and forth over and over again. Let's go ahead and see what happens. And I don't even need to see the game. I can just look right here and see this. Let me turn off maximize on play. I can see the scene. There we go. So we don't even need the character just yet. We're just testing our prefab, and yeah, that's exactly what's happening. Is it's spinning down here and it's idling for a very short second and then coming back to spinning. And this auto live link right here, that's what's actually giving you that updating information, and you'll see when it's transitioning that those arrows get a streak of blue on them as well. So now what we want to do is set up that to not constantly be going back and forth, acting all strangely. So and another quick thing is if you make a transition that's not what you want, there's no option to actually delete them, so you're stuck with them forever. You just have to stay with them. No, that's not the case. You can just hit function delete on your keyboard, and it'll delete the transition. That's the way to do it. All right, so to set up our actual conditions for when we want this to trigger, what we want to do is create a parameter. All right, so I'm going to create a Boolean. I'm going to call this toggle spin. All right. So now that we have this parameter, and now it's basically we can set it to be true or false, and we're going to eventually set that in a script. Over in the transition here, so to go from idle to spinning, we only want that to happen when our parameter here is set to true. Right? We want to check this value to actually transition back and forth. So I'm going to go ahead and hit this plus here on the conditions. And now it immediately just adds the parameter that we have because we only have one. If you have multiples or you're using more than one, you can pick from that list right down here. And now here is the value that we want it to be set to. So we want it to be we want it to transition to spinning when toggle spin is set to true. Now over here, we want to go over here, set toggle spin to false. Okay, so now what we can do is when we play and just go to the scene mode, now you'll see it's off and it's looping and idle over and over and over again, right? So now if we hit toggle spin, hit that to be true, now you're just going to stay in spinning over and over again and just stay looping until we tell it to turn off. And now if it's taking a second to actually turn off or on, that's because Unity is waiting for the animation to actually finish. So let me see if I can time it right. And I'm gonna turn this off as soon as the animation starts. And notice that the whole animation is going to finish before it actually transitions. See that? It totally waits the whole time. That was part of the reason why I made my idle short. That's one way to get around that. Also, you'll notice in the, let me go ahead and stop this. In the animator, wait, I just closed it. Select the pivot. So in the transition here, you'll see this has exit time. Basically, by turning that off, that's going to, as soon as it wants to transition to the next state, it's going to transition immediately. So if you wanted to like add in that wind up, like say you have a new state in here, I'm just going to show you the concept of it, but not go through the setup. So this would be like wind up. And this is kind of a hint to, it should include something like this, because this is a hint to doing your actual entryway itself. So we could do something like this. Right? So it's in idle, it does that wind up play animation, and then it goes right to spinning. And then it could have that shut down animation. This is a really clear layout to what you're actually going to be doing for, this would be like a shutdown. For your door, right? You're actually going to have 4 different states. So we're just going to be working with these two, spinning and idle, on and off. But if you think about it from a logic standpoint, all we're doing here is this. Is going to play this passing through motion, right? So this would be, if you think about a door, we have closed and open, right? The door is closed, and now here the door is open, just idle open. But here, this is the opening animation. This is the closing animation. Actually, the door actually opening and the door actually closing. It's just passing through, we're just passing through the state and going to the next one and waiting. So that's what you would add in here, would be those. And then this is where you can start to adjust those exit times to not have an exit time here. So as soon as it starts shutting down, it just transitions from spinning to shutdown right away. So after all of that, basically what I was trying to get to was that that exit time will control that that motion and that clip from basically playing or transitioning at a certain point in time. Also, you'll see when I add in select the transition, you'll see this little graph down here. Basically, this is showing you how much time it's actually taking to transition. So you could elongate, make this a bit longer, so it's going to basically blend them together. Much more useful with characters and things like that, but still things you can adjust and control. So let me add these transitions back in here real quick. But yeah, there's a good hint that right there, if you think about the wind up and shutdown, which I should definitely incorporate into the assignment. So if you want to do so, that'll definitely help you work with the entryway, because there are 4 states to the entryway itself. So let me just make sure it works now that I had adjusted everything. Staying idle, starts spinning, goes back. All right, cool. So now that's the case. Question?
Yeah, if you're designing a level and you want a wind turbine and you figure it's always going to be on, is the idle necessary to have?
No, no, you don't need it. If you just want it to be an aesthetic thing in the background, you could just have the one clip and it's always spinning. Definitely, it's how you want to use it, really. It's up to you. The reason why we have the off is because we want to be able to control it in this demonstration. So I'm going to go ahead and save the scene and save the project. So now remember, dangerous stuff right now is because we didn't actually check anything out with Perforce. So for example, in theory, if I were to be, say I was working with a team, or one of you guys came in here and made changes to this project, we were working together on something, and I didn't yet submit to Perforce, and I just go and get latest revision. So what this would actually do right now, if changes were made to the project, it would take all of the process I have made, all the process I made on this work would be lost, right? Because get latest revision is copying what's on the depot over to the workspace, right? So by not checking out the files, Perforce doesn't recognize we have changes yet. Everyone understand why? Because I haven't checked anything out. All right, so what I can do is what's called a reconcile offline work. So what this is going to do right now is it's going to scan whatever folder I have selected. And remember, I added, actually let's go back to here and let me make sure my prefab is saved. And how I want to do that is because the thing I changed was on the pivot object, I now have an animator that's new. So I want to go to the wind turbine and hit apply. I just want to do that real quick just to make sure that gets updated on Perforce. Save scene, save project. So back here. So think about the things that we've done, right? Always be conscious of the changes you've made. I'll never forget the student I was working with in Unity Lab, and he's like, yeah, I've got my door. I'm trying to get it to open, but it's telling me null reference exception on my object. I'm like, okay, go to the script where you're referencing that object. And he goes, what script? I was like, the script that it's talking about. He goes, how do I know I wrote that script? And I was like, did you write the script or not? Like I couldn't help him further from that. So the moral of that story is just be conscious of what you're changing. Yes, there's a lot of files in here. Yes, there are meta files and it's complex. This stuff is hard. I'm not going to tell you this is easy because it's not for everyone. It's technical and it's complex, and you have to be aware of the changes you're making. So what reconcile offline work can do is help you catch anything you may have missed. So what I'm showing you, I'm not showing you because this should be your workflow. I'm just showing you how this process actually works. So because I made changes in multiple different folders, the safest thing I can do right now is just do it from, I can do it right from my assets folder. And you'll notice when I do reconcile offline work from assets, it's going to take a second or two to actually scan every single file. Right now it's going through every single file on my computer to see what's different or what's new. So this window pops up. This window comes up here. Definitely don't just immediately see this window and hit reconcile. I see students do that a lot, even with change lists and things, where you just immediately just move on to the next thing. Actually see what it found. Like, so if we look at this window, it's broken up into 3 separate categories, right? Modified files, in parentheses says things that were checked out. Here is the new files, so things that are not in the depot, that all these are going to be marked for add. And now down here, anything that's missing. So if I deleted from files from my workspace, those files would now be marked for delete because they're not appearing in my workspace. So when I actually hit reconcile, what this is going to do is add these files to the change list. When I hit reconcile, it's not going to submit them to the depot. A number of times I've also seen that where you hit reconcile offline work and then think you've submitted. That's not the case. Same thing with mark for add. You can't just hit mark for add and it's on the depot. You got to hit reconcile, or you got to actually submit. Sorry. So when I hit reconcile, now these files are in my change list, right? I've got these files checked out that were modified, all these new files here. Now I can submit this. So you can see I'm ending up in the same place, right? The problem with this is that the things are marked as read-only and there's no communication to, again, when you're collaborating with others, to actually say I'm working on these files. The best way to do it is actually check them out. So get in the habit of checking out files, working on them, and submitting, and knowing that you have that reconcile offline work to catch anything. Maybe if you miss something or you want to just do a scan to see what it finds, it's there as a resource, but not necessarily a good workflow. So I'm just going to say completed experiment number 2, and I'll say practiced. So I definitely want to make you guys understand why that could be detrimental. Because if you do a get latest revision, like, you know, say someone tells me, hey, I made a change, want to go ahead and get my files and test it out on your machine, I'm like, okay. I go ahead and get latest. Before I do that, all my work has gotten wiped away. So does everyone understand why that could happen and that process? Anyone have any questions about that? All right, so be careful when you're working on that. Try it out and understand it, but make sure you understand checking out and mark for add first. This is much more of an advanced technique. This isn't a magic button, fix everything, make me not use Perforce. This will make things more complicated if you don't know what you're doing, or it can make things a lot easier if you understand it. Double-edged sword. So, anyone have any questions about experiment number 2? The animation window, the animator, setting up the prefab? No? Okay. So back to, I'm going to go back and actually check out the things I want to change. So real quickly, I'm going to check out the wind turbine scene and the meta file, as well as I'm going to be making changes to the prefab. So let's see, that's in my student name folder, prefabs. Let's go ahead and just check out the prefabs folder. So also remember that all that stuff that we've created, so inside the animations, that pivot controller, right? That is something that also could be changed. If you're adding more, states to your door, or you're adding more parameters, things like that, this will change, as well as the meta file. So the idle, these clips, if you go back and make clips or adjustments to your actual animation, make sure you check those out as well. So the next thing that we're going to be doing in experiment number 3, how you guys doing? You feel like you need a short little break? Want to take no, I see. No? All right, Brent, you're responding. So Brent says no, we're going forward.
Why was that a deciding factor?
You're the only. All right. We can if you want to. We're doing good on time. All right, well, it's 1-1. Anyone else have a vote? Okay, we'll take a short break.
Excuse me.
All right, so I'm going to delete that folder just because I don't need it. I'm not going to have anything in there. So inside that package, you have those two sound effects, the clip and wind loop. All right. So now what we want to do is go ahead and create our trigger volume for the player to actually interact with. So I'm just going to create a level blocking cube. This is just going to be our little control station that the player is going to walk up to. Let's make it a little bit larger. All right, and now on here, let's just rename this control station. And then inside this, I'm going to right click and create an empty. And let's make sure it's clean. And let's call this control trigger. Okay, so now what this object is going to include, this is going to be our actual trigger volume. So if I'm going to go ahead and add a component, let's add a sphere collider. All right, there's our actual trigger volume. So again, this should be a refresher. A little bit from PMP1, I'm sure. You guys went over the collider component. But this edit collider here, you can select that, grab little faces to make it bigger or smaller. Notice that all that's actually doing is adjusting the radius. So same way to accomplish, or two ways to accomplish the same thing right here. So go ahead and do that. We can move this into place to make it centered on our trigger volume or on our station. Make this a reasonable size. Let's make this 0.4. And definitely something to pay attention to when you actually set up your entryway. Don't make your volume too large or too small so the player can't actually interact. Make it a reasonable, like realistic size. Usually about 1 to 2 units, like 1 to 2 units on the grid is a good amount using the level blocking meshes. So we want to make sure that this is checked is trigger. So not doing so, we're not able to actually use the on-trigger enter, on-trigger stay, and on-trigger exit functionality that Unity provides to us. So make sure that's checked on. Next thing we're going to do is let's add a new script to this. Let's call this control turbine. All right. So if you take a look at the actual experiment, you'll see that the script right here that you are going to be writing is provided for you, but we've done it so it's in an image, so you can't just copy and paste it. You actually need to go through and write the script yourself. So what I'm going to do is write it out. I'm not going to be including line or comments and things like that. I will be explaining what each line is doing and things like that, but refer to the comments in the code itself to actually understand it if you need more clarification. So with that script down there, I'm just going to double click and it should open up Visual Studios. So if you guys are using MonoDevelop, that's totally cool. I prefer Visual Studios, and I think just overall there's a lot of things about it that are a little bit better anyway, so I recommend it. One thing that you should have on though, whether you're using Visual Studios or MonoDevelop, is the line numbers. So I think in MonoDevelop it's on by default. In Visual Studios it isn't. So if you go to Tools, Options, and now it's buried in here, so let's see, it's Text Editor, All Languages, line numbers right here. Make sure you check that on and then hit OK. So this makes it much easier for other people to look at your code and be like, line 15, you're missing a semicolon, or very easily to point out. It's much harder than without them. So make sure that they're in there, and it's also easier for yourself as well. So again, in this script, what we're trying to accomplish is we want to get access to that animator object and be able to change that Boolean on and off. And from there, when we're actually able to change it, we're going to allow the player to actually change it based on an input. So what we need for this is the first thing we do is we actually need to get access to the pivot object, right? We need to find that turbine pivot. So we're going to create a public game object, and we're going to call it turbine pivot. The reason why I'm calling it this is because that's just to reference that that's going to refer back to the actual pivot object that we've created in Unity. So I'm just going to save this script and showcase back inside the hierarchy. Let's see, select my control trigger. I'm going to have to move my hierarchy to right here. So select my control trigger, and now you'll see on my script, because it's a public game object, we have it exposed in the actual inspector. So here it's looking for an actual game object. So what we want to do is click and drag the pivot into the control turbine spot, right? So now that's being referenced. In the actual assignment, that doesn't happen until a little later on. I think the order isn't the way I prefer to do it. I like to make sure it's plugged in as soon as I create it. It's a good habit to get into. So now that that's plugged in, we've got now our script has access to this turbine pivot. Whatever object we've plugged in there, right? Right here, whatever object we plug in, we now have access to that object and all of its components. So from there, we're going to need to create an actual animator, because we want to get access to the animator of this object and set it equal to one that we're creating. So we're going to make a private animator, and we'll call this pivot anim. That's a reference to the animator component of our pivot object. The next thing we're going to need is a Boolean, right? So we have a Boolean inside of our animator. Pivot. So we have this toggle spin, right? So what we want to do is set this equal to another Boolean inside of our actual script. And we set them equal to each other. That means if we change one, the other one will be changed as well. So we're going to create a private Boolean. And we're going to call this is spinning. All right. So that's what we're going to need to actually get this to function. We have our public game object, we have our animator, and our Boolean. So inside of our start function, anyone want to tell me what the start function is? If I delete this. So start happens as soon as the game loads. So the very first frame, there's a wake and then there's start. So as soon as I hit play in Unity, start happens immediately. It's the first thing that happens in the game. So update down here, you'll see that this comment that Unity provides, update, is called once per frame. So ideally, games are 60 frames a second, 30 to 60 frames. That means whatever you put in update, that's happening 60 times a second. So be careful with this. If you put a lot of functions and a lot of processes for the computer to do every single frame, it can very much impact your actual frame rate of your performance. So in start, what we want to do is we want to actually get that animator component of this object. And we want to set it equal to this one here. So on start, what we're going to do is we're going to say pivot anim. And there you'll see that once we've already created this up here, it's auto-completing for us here. So we have pivot anim, and we'll say equals turbine pivot dot get component. And now this is a function as well, so we need parentheses. So inside the carets here, we can say what is that component we want to get, right? So our pivot anim is an animator, so we should be getting the animator component. OR, and then we need a semicolon. So you'll see that if I tried to put anything else in here, say I wanted to get the transform, oops, it should give me an error. Yep, because it was going to tell me I'm trying to set it equal, cannot implicitly convert type transform to animator. I'm trying to set an animator equal to a transform. And that's not the case, right? An animator has to equal an animator if you're thinking about it logically. So now that now this pivot anim, right, this private thing that only exists in my script, now whatever this is set to this actual animator component in Unity. So I'm actually just going to go select it to showcase this animator component right here, this guy. So if I go ahead and close this window and then double tap on this pivot controller, that'll open up my animator, right? So we now have access to the actual animator component. So inside update, one thing we are going to include here is this Boolean. We want this Boolean to equal our toggle spin Boolean inside there every single frame. So that is how we are going to utilize the update. So every single frame we're going to set is spinning equal to the toggle spin Boolean. So here we're going to say is spinning equals pivot anim dot get bool. So we're actually getting the Boolean here. And remember the dot operator as well. So when I put the dot at the end, I have, the period, I have access to all of the functions or all of the properties I can call off of pivot anim. So you can see here, get Boolean. All right, so now in the parentheses, what we want to say is what is the name of that Boolean we want to get, right? And that was toggle spin with a lowercase t and a capital S. What's up, guys? So you guys have a question or something? There's a lot of talking going on. All right, so now that those are going to be equal to each other every single frame that the game is running. So moving on, you'll see the next three functions are pretty similar to each other. So on trigger enter, on trigger exit, and on trigger stay. So I'm just going to go ahead and write void on trigger enter. So make sure that you're using this this casing right here. If you do something like this on trigger enter with a lowercase t, Unity is not going to give you any problems. You're not going to get any errors. Everything is going to be normal, but your player isn't actually going to work. And the reason why it's giving me that error right now is because I don't have I don't actually have the whole function yet. But there you go. You'll see that now it's not complaining at all. The reason is because it thinks you're just creating a new function called onTriggerEnter that's different from this one. This is the one that works with this inside here, right here on the mesh collider, or the collider itself, is trigger. That is what onTriggerEnter, onTriggerStay, and onTriggerExit actually work with. So make sure that you have that proper casing, the capital O, capital T, and capital E. So in here, we're actually going to be looking for the collider, and we can just call this entity. Here we can name it whatever you want. You could call it player, you could call it Bob, you could call it pineapple. It doesn't matter. What's important to understand is it's just something that we can reference inside of this trigger. So inside of here, we can write an if statement. So if entity.tag, and we're going to check for the actual tag, and we're going to do a double equal sign, and then we're going to search for the tag player. So if something that enters the volume is tagged as player, this next if statement will actually run. So can anyone tell me the difference between a single equal sign and a double equal sign?
Single you're setting, double is it's looking for that.
Exactly. Yes. So single is you're setting it equal to each other. So assignment versus comparison. Here we're just checking, is this entity's tag equal to player? If it is, do something else. So exactly, assignment for one, comparison for two. So now inside here, we can just write a short little print statement. So for these. So go ahead and enter on down. And just so you know, you don't, if your if statement is only one line, you don't need curly braces. It will function normally. If it's more than one line, you need curly braces. I always like to have them in there anyways, especially I'm very particular. I like to have this formatting as well to make it very easy to understand where a curly brace ends and begins, because I didn't go to school for scripting and writing code. I was in Maya, modeling, and in Photoshop doing textures. So a lot of this stuff I've been learning the last 4 or 5 years, and I'm still doing what I can to make it easier on myself. So don't make it harder. Just stick with the formatting, and it'll definitely make your life a lot easier. So just on this line here, I'm just going to have a print statement. And this we just want to check to make sure it's working. So basically I'm just going to write the player has entered the volume. All right, and now because code is awesome, we can just copy and paste this and not have to write it 3 times. So I'm just going to copy this whole function and paste it twice. All right, and now all I'm going to change down here is we want to change this to on trigger stay, on trigger exit. All right, and then let's just change this to say the player is in the volume, player has left the volume. All right, so that looks pretty good. Let's go ahead and save that and give it a test. Let's come back to, so now we are going to need the scene, or the actual hub. So let's save the scene and drop in the hub. So another issue that I've seen with Unity, I think this is just a bug with 5.3 or one of the more recent ones, is this issue here, to where I was working on the scene, now I want to add in the hub. Well, now you'll notice that actually the wind turbine is the higher priority than the hub. This shouldn't be a major issue. I have seen some visual graphical issues to where whatever scene has the main camera, which if you look on the character in the camera system, there's this thing tagged main camera. This is helpful for Unity and it's required for the game to run. When it's not that root scene, there's a really weird sorting issue with the camera itself. So remove the actual scene itself and then add it back in. So make sure the hub is the priority. Wind turbine. All right, now let's go ahead and test this out. Now all I'm testing for here is, let me make sure I can see my console, is I want to see those print statements. And make sure you have collapse on. It'll definitely make it a lot easier to actually look at all of the different ones. So okay, so I walk into the volume. So there you'll see I enter the volume. And now as long as I'm in the volume, you'll see that's continuing to tick up and tick up and tick up. And now when I leave, it'll tell me I've left the volume. Right? So now we know our trigger is working. It's recognizing the player is entering, it's recognizing they're there, and it's recognizing they're leaving. So just looking at those numbers, does anybody want to take a guess as to where we're going to actually check for player input? Are we going to check for it when they enter, are we going to check for when they're in the volume, or when they leave? Why would you want to do it when they enter? So if you do it when the player actually enters, take a look at how many times those are actually being called. So I'd have to press E the instant I enter the volume. So I have 1 frame, so 1/60th of a second to press E at the exact right time. Right? So if we do it on trigger stay, you see how that number's constantly ticking up? That's just waiting. That'll just be waiting for our input, right? So it recognizes we're hanging out and we're staying there. So we're going to put our player input on the on trigger stay. So enter and exit are still useful, right? Like from a design standpoint, you could think, you're walking up to a doorway and then you enter a volume and just stuff crashes down in front of you and blocks your path, right? A good use for enter. Or you have lights turn on when the player enters a volume. When they exit a volume, you could have part of your scene unload or have some light turn off, things like that. So still useful, but for player input, you want to put it in on trigger stay. Alrighty, so to get that functionality to work, we're going to put it right inside this if statement. So inside this if statement, if it's tagged as player, we can go ahead and put another if statement inside of here. So if input dot, so there's get key up, there's get key down, and get key. Basically, they're all pretty much self-explanatory. As soon as you push down, it'll happen. Get key up is when you let go, and get key is basically as long as it's being held. So if you had like a machine gun or something, you basically, as long as the player is pushing a button, continuing to call a function or continuing to shoot a weapon, that's what you'd use get key for. So get key down is when they press, and get key up would be if they let go. So we'll do a get key up, or not button, get key. I think button is for a controller. All right, and now this is a function, so we need to say what button it is or what key we actually want to press. So if you type key code and then do the dot operator, you'll see every single key on your keyboard. So you have access to every single key on your keyboard. We're going to stick with just the standard interact key that is PC, which is E. So make sure that your entryway is pressing E and nothing else. All right, and then so if we do the double ampersand, what this can represent is we can check for two things in an if statement, right? So we can say if the player presses E and our Boolean is set to a certain value, execute this function. Another one that's helpful is it's the backslash right underneath the delete key. You hit shift and then the double bars. That is OR. So basically that means, I don't think it's, yeah, that should be a thing. I think it's because it's yelling at me because of this. There we go. So this means OR. So you could say if the player presses E or they press F, you know, do this thing. So both of those are pretty helpful. We're going to be using the double ampersand. So if they press E and then our is spinning is set to false. So and remember, this is spinning here. This is spinning is set to our toggle spin. So it's checking if this one is false, that means this one is false, right? So if this one changes, this one's immediately going to change. So now what we want to do here is, so if they press E and if is spinning is false, we want to change our Boolean, right? We want to change our toggle spin Boolean. So pivot anim. So up here we did a get Boolean. Instead down here we're going to do a set Boolean, set bool. So this is very similar to where we need to say what is the Boolean we want to change. And if you hover over the function itself, you'll see right here it says the string name and the bool value. So basically we need the name and then also the value that we want it to be set to. So it's comma true. All right. So if they press E, if they're in the volume, if they press E, if is spinning is false, we're going to change the toggle spin to true, right? And by changing it to true, that's changing is spinning to true as well, because these are set to each other. So now that's the case, let's go ahead and move this over. And now instead I'm just going to change this to say the player has activated the wind turbine. All right, let's go ahead and save this and let's test it out. Let's go back to Unity. So now when I go ahead and play, and I'm going to pull off my animator window so you can see the Boolean change. If I did everything right, you'll see a change. All right, run over here. So now when I enter my volume, all right, it knows I'm there. I press E. Oh, this auto live link like works basically 90% of the time, and then most of the time it won't. Is it working? Anyways, of course, I wanted to show you, and it's not working. But you'll see that it is actually animating. So yeah, that auto live link works most of the time. But now you'll see that that is updating as it should. But you'll notice that we can't yet turn it off. So what we want to do is go back to our script and add in the functionality to actually get this to shut off. Anybody have any ideas what we need to do? Not sure? Well, what do we do to actually turn it on, logically, from a logic standpoint? What was the thing we did to turn it on?
Have a trigger checking. player's in a certain area, and if they press E, it turns it on. So do something similar, except backwards to turn it off.
Exactly. So what we did to turn it on, right, was we just changed that toggle spin to true. So what we want to do is change that toggle spin back to false. All right, that'll shut it off. So what we can do is take this if statement right here and copy this. And this should all still be inside the on trigger stay. All right, and now here it should be toggle spin is set to false. Oh, not flashlight. And here, so basically if it's true, so if they press E and is spinning is set to true, then we're going to set toggle spin to false. So let me make sure I've got my, I'm missing some curly braces. Alrighty. So now let's go ahead and save that and test it. All right. Something's, oh, the print I took out. All right, so there we go. It turns on. I press E again, and it turns off. So my prints still say activated twice, so I can go ahead and adjust that. But now I'm able to turn it on and off. There we go. So now you'll see I'm able to, actually now you can see that, so I just had to close the animator window and open it again. Again, it's a little finicky, but most of the time the auto live link works. And now you'll see that that is actually turning from toggle spin true to false as I'm pressing E. All right, so now the last thing to do is add in that those sound effects that we had first imported in. So, man, my project layout just keeps changing. Keeping you guys on your toes. So in the project, right, we had those two audio effects. So in assets, the click and win loop. We want to actually add those to basically when the player presses E, we want to hear that click sound effect, right? Giving the player some feedback as to what it is they're doing, just some feedback from the system. So what we want to do is select our trigger volume. So again, I know you've probably had a little bit of a familiarity with the term of object-oriented programming, to where whatever it is that you're being affected, right? If the player has some type of script on it, we don't want to put that script on anything else but the player, right? Whatever has that functionality, that's where the script belongs. Think about the same thing from terms of audio. What is the thing making the sound? Put your audio on that thing. It's the best way to keep yourself organized, as well as utilize the 3D sound effects in Unity. By default, the sounds are 3D, so the closer you are, the louder it is. The farther away, the quieter it is. So wherever the audio is coming from actually matters. So on our trigger volume, our control trigger here, I'm going to go ahead and add a component. I'm going to add an audio source. All right, so now I got my audio source added. First thing we want to do is actually plug in an audio clip. So I'm going to drag in my click sound effect. And now, just to make sure it's working, always a good thing to do is, by default, this play on awake is on. So if I go ahead and hit play, we should hear that sound effect. All right. So now we know it's working. The WAV file that we've imported actually works, or the WAV file. So that's a good sign. So now the next thing we want to do is adjust the audio to be the way we want it to. So in the inspector, select the control trigger. We want to turn off this play on awake. So down here you can actually adjust the you can adjust some of the 3D sound settings, so the minimum and maximum distance. You can play with these values to see how the volume that you want, as well as this curve. So just adjust some of this if you want to, as well as you can always click on this little help document and it'll explain every single one of these attributes. So now that that's functioning, we want to actually add this sound effect to the script, right? Actually get reference to this and adjust that sound effect at the right time. So in here, we're going to create a private audio source. Not a chorus filter. All right, and let's just call this control audio. So this is like our control station audio. Okay, so then what we're going to do is in the start function here, very similar here. So where we have pivot anim dot turbine pivot dot get component. So what we're going to do here is we want to get access to this component in a similar way. So this audio source on the trigger volume, so here's this control turbine script, and here's this audio source. We want to get access to this audio source. So what we're going to do in the script is something very similar. We're going to say control audio. Does anyone have a guess as what we can say here? False. Not quite. I like the effort. So it's right here, right? So we're going to do, instead of getting access to the animator component, we want to get access to the audio source component. So what I can write here is get component audio source. And now while I'm writing this, does anyone have any idea why I don't have to define the game object? How come I can just write audio, I can just write get component here? It's a good thing to understand the difference.
Because there's only
One what?
one sound controller?
Not quite. The reason why is that this turbine pivot, this is referencing that this object, this component is on some other game object, right? This turbine pivot is actually referencing this pivot object, right? The actual pivot that's rotating. This audio source here is on the same exact game object as this script is. So again, object-oriented programming to where I'm able to just say get component because it's on the exact same object. I'm getting the components on the same object as what the script is referencing. This is referring to another game object .get component. So this is pivot .get component animator. So now that we've got access to the audio source, it's as simply as saying at the right time, let's say change this to deactivated. In here, basically, when we set this Boolean, we want to just play our audio, right? So control audio dot play. And that's a function, so we need parentheses. And now we're just going to copy this and paste it in this line as well. So basically, every time they interact with this console, they're going to hear that click sound effect. Let's give it a test and make sure it works. So this isn't the only way to do audio. There is another way that I will showcase next week. So there we go. You hear this click sound effect. The motion starts happening. I press E again, and it turns off. All right? So there's the first sound effect implemented. The next thing we're going to add in is we just want to have a little bit of ambient wind noise when this is actually turned on. Just a little bit more feedback so the player knows this thing is turned on. So for this one, since the wind sound effect is actually coming from the pivot or from this object itself, we're going to put the actual audio source on the pivot object. All right. So create an audio source. Drag your wind loop sound effect into the audio clip. And now again, we can just test it and make sure it works. You should hear a real subtle So wind noise. All right. So we're going to turn off play on awake, and this one we're actually going to have it loop. So we're going to check this on. So as long as it's playing, it's going to play over and over and over again. All right. So from here we can go back to the script, and just like we did here, we're going to create another audio source. Just copy paste, and instead of control audio, let's call this guy wind audio. All right, and then just like we did here, again, work smarter, not harder. All right, and now change this for control audio to wind audio. And now again, right, remember, like I just explained, we can't do get component audio source because this is going to get the component of the actual game object. So here we want to define our turbine pivot again, right? So our object that is pivot, get component audio source. That way we know we're actually getting this audio source right here. So pivot audio source. Hopefully you guys can make that connection between the difference between these two. It took me a minute. It definitely was like I definitely had an aha moment where I was like, oh, it's just referring to the game object, and whatever components are on this are what I'm going to get access to directly. All right. So whether it's an animator or an audio source or a transform, no matter what it is, understanding this, that components are components and game objects are game objects, will be much easier for you to wrap your head around. Whether you're animating a cube or you're animating a light to turn on and off, same concept, right? Still a game object, still the same concepts in terms of animation. So we've got our wind audio. Come on down here and we'll do wind audio dot play. All right, and now this is going to play, because we set that to looping, it's just going to play forever. So we don't want it to do wind audio dot play down here. If we just do the dot operator and take a look at what our options are, you'll see we have one called stop. This is basically just going to stop the audio. All right, so now when they turn it on, you'll hear the sound, and the wind will turn on, and when you turn it off, you hear the control audio, and then the wind will stop. So let's save that. All right, and let's test it out. All right, you hear the click sound effect and the wind going. Now when I turn it off, the wind stops, and then you hear the click as well. All right, so everything is functioning as we want it to. So from here, we made some changes to our prefab. So what I should do is, let me double check in Perforce. Okay, I did check out the prefab, good. All right, so everything is functioning. Let me go ahead and apply my changes to the prefab. Let's go ahead and save the scene, save the project, come back to Perforce, and let's see. So if we take a look, what I had checked out was the scene in the prefab, but we've added some new files, right? So we added the script right here. Here's the script and the meta file. And again, these little icons are a great way to utilize, very easily being able to tell what has changed, what's new, what's on the depot and what isn't. So I'm just going to drag in my new script, and that should totally be in my scripts folder. I can change that. Let me go ahead and I'm going to go ahead and select these two guys and revert, because I want to move that first. There it is. So what Unity does by default, because how I created the script, when you go new script, it just drops it in your assets folder. So it doesn't necessarily know where it should be, so you definitely want to be putting it in the right location. So I'm just going to drag it in there, then come back to Perforce. Now it's in the right spot. When I hit refresh, just a little thing to stay organized. All right, and then what else did we change? We have the sound effects, right? We added those sound effects. Here they are. Just drag those guys in there and then hit submit. So yes, Perforce takes some time to actually submit the files, but it's worth the time that you're taking to rather than losing a bunch of work. As if anyone was here when Jacob had said this morning, it took his team 6 hours, roughly about 4 to 6 hours to get their project figured out on Perforce. So staying organized and actually submitting your work often and double checking it's correct will save you time. So this class in level design, it's really about forming habits. So I'm telling you guys, submit to your working folder. I do what I can to show you how to. But I'm not going to be micromanaging you and parenting you and double checking. I take a look and see, but it's really up to you to start to develop these habits and check in often. So when you get to the project class, you know what you're doing, you feel comfortable, and you're not destroying the team's project. So now that's completed. Now I can see, and this is what you'll do when you're done with all 3 experiments. You can select your project folder, and now you'll see I have completed experiment 1, 2, and 3. So then just take a screenshot of this, the date, this will show your user and then your description right there, and submit that to FSO. All right? So that is all the information that you need to actually build the entryway. So we didn't actually show you how to make a door, but you now know how to make a door and how to get it to open and close. So this, in the entryway assignment, this is like the default, this is the base requirements of the assignment. So if you don't feel like you're very comfortable with this kind of stuff, you're still learning it, stick to this. Don't do anything over the top just yet. Stick to this, make sure you can demonstrate these skills before you do something a little bit more elaborate. If you feel like you can get this done, or you make this and use this as your safety door in case anything goes wrong, and you want to do something a little bit more creative or a little bit more unique, you can have, you do have options. You can create something that is a little bit custom, maybe something you want to build and include in your level in some way. This student in particular, he ended up using this specific entryway as a giant like hangar ceiling that opened up and a helicopter dropped in. So he ended up using this in his level. It was actually in the example, the Team KL example you guys played. At the very ending, this was this entryway that he built. Here's another really good example, and we have a minute or two. I can just pull them up and show you guys how they actually play. But yeah, that first one that I had seen, that I just showed off, this one, when I saw this, when he turned this in, I was so blown away. You probably would have made fun of me if you saw how excited I was about a doorway. But he had these hinges and the plates, and everything rotated and moved like a normal door would. And just his attention to detail was very, very on point. Like he had like the little kick plate down here that was textured differently than the frame. He had the doorknob and the little latch, inside the door, the thing that catches in the door. Had just all the details. So really, very well done. And you can definitely, you don't need to do something really creative to get like an A+. You know what I mean? You can do something very well executed, and you'll be all right. What's going on? So it's telling me let's see if I've got these files. I may have to copy them again. Yeah, I don't have them. All right, so I can show you these in lab, and I can throw them up on Perforce if you definitely want to check them out. There we go. But these are 2 really good examples. So if you want to do something more creative, because the assignments require a handle and a frame, so you can do something a little bit different. Don't just give me a regular door with no handle and a button I press to open it. Please make something that is like somewhat realistic to something that would exist. If you want to make a little control panel or something and the door actually animates in a cool way, go for it, but don't give me a door like that with a button to push. Just stick the handle on instead. So his was a really good example of he set his up in a hierarchy in a way to where he could animate one animation, all 8 pieces move at once. Right? So he basically has his animator object and all 8 of those pieces, he animates each one, but you just basically change one Boolean and they all rotate like that. All right? So yeah, if you want to do something different, if you want to have really the handle, what that is, the purpose of that is basically as an interaction point for myself and for a user. So if I walk up to it, where's the spot I go and press E? You guys will learn in level design how to actually like print stuff to the screen and have text and things like that. So for now, it's just about where's the interaction point. So this one's a little different. He definitely went above and beyond to where I push that down. You see his eyes light up as a piece of feedback. Really, really good attention to detail. Go and hit this one. So now it's in the open state. And what he did was something really cool. And if I walk up to it, so that's a trigger. That's a trigger event. And we can, next week, I can go into a little bit more detail about how to actually use it. So basically when I hit that volume, it triggered, went to a new state, went to this byte state, and then returned back to the open state. So you can play around with that and trying to experiment, and then we can definitely review it a little bit more. All right, so he did such a great job, and please don't do something like this where I can't get out. But he walked through, and there's this. So I'm stuck now. I can't get out. You should be able to, it's really important, you should be able to open it and close it from each side, so include that in your entryway as well. But this one was just a really good, huh?
He almost got a 0.
He almost got a 0. But no, that was very well done, and all that too was done with, can't get out now, all that was done with level blocking meshes. What?
Why he almost got a 0.
Yeah, it was basically because there was requirements that you need to meet, so we want to be able to go back and forth through each side of the entryway. So make sure you're sticking to the rubric and to those requirements. No, because of the button, those 2 buttons, right? So if you do something else, those are the interaction points for me to go to. But don't just have like a regular door with a button, right? If you're going to do something traditional, just stick with the handle anyways.